Hello friends, welcome to Zeta Axis, and today we will discuss about special volcanic regions. We have already discussed the process of formation of volcanoes, different mechanisms due to which volcanism occurs, as well as different types of volcanoes. The link of all this video should be available in description. Today we will see special volcanic regions. We will try to understand why so many volcanoes are concentrated in these regions. We will see the Mediterranean region, then we will see why no volcanoes are there in India, then we will see East Caribbean region, we will see African Rift Valley, Southeast Asia, western coast of North America and western coast of South America. We have already seen this map, and from this map we can easily understand that volcanoes are concentrated in the tectonic boundaries. More specifically, they are concentrated in subduction zones. Based on this map, we can classify the volcanoes in three different regions. The first is Circum-Pacific Belt or Pacific Rim of Fire. This is a belt surrounding the Pacific Ocean where we see a huge concentration of volcanoes. It starts right from New Zealand, it goes to Asia, North America, South America. In fact, there are certain volcanoes in Antarctica which can be included according to some reference into the Circum-Pacific Belt. This is a map where you can see the important trenches as well as important mountains. Another region is Mid-Continental Belt. It includes the Mediterranean volcanoes as well as the volcanoes of Rift Valley of Africa. And then is the Mid-Atlantic Belt, where we see a lot of volcanism occurring along the mid-oceanic ridge of Atlantic Ocean. Here is Iceland, and some parts of even Greenland are part of these regions. But today we will focus on special volcanic regions. So let's see the first region, that is Mediterranean region. You can see that in Mediterranean region we can find a large number of volcanoes. So let's try to understand why there are so many volcanoes in the Mediterranean region. We already know that Mediterranean region is a remnant of Tethys Sea. Tethys Sea was a sea which existed between Africa, India and Eurasia. It was a very big ocean. But due to the movement of African plate and Arabian plate and Indian plate towards the Eurasia, that ocean has disappeared now. Mediterranean Sea is only a remnant of it. So for millions of years, African plate and Arabian plate have moved towards the Eurasian plate. So a compression force existed in these regions. And because of these compressive forces created by the movement of Africa and Arabian plate towards Eurasian plate, a force was applied, and due to which these regions got divided into very large number of small plates. We see there are many micro or minor plates here. Anatolia plate, Aegean plate, Adriatic plate are few of the important plates. Now each of these plate has independent movement. They move in independent directions with respect to each other. Now we already know that the seismic activity is concentrated on the tectonic boundaries. Now here, because there are so many minor plates, there are large number of tectonic boundaries, as you can see. There are many small regions of subduction you can see over here. So because there are so many boundaries here, we see a lot of tectonic activity happening here. There are so many subduction zones which creates volcanoes. There are so many continent-continent collision zones which have created mountains like our Alps, even Zagros here. So this region is tectonically very active because there are large number of minor plates, and these each plates create tectonic boundaries, and we have already known that tectonic boundaries are rich site for formation of volcanoes. If you see this map, we can see some of the mountains that were created because of tectonic activity as well as the subduction zones. Even Aegean Sea has a back arc because of the subducting plates. So we see that this region is tectonically very active because of large number of plates having large number of tectonic boundaries. Now quickly see all these points. The Mediterranean Sea is a remnant of Tethys Sea, which we have already discussed. Mediterranean Sea region is sandwiched between African plate, Arabian plate and Eurasian plate. Both African and Arabian plate are moving towards the Eurasian plate. Thus a compression force exists in this region which has divided the plate into large number of micro and minor plates. These plates move in relative directions. All the plates have independent movement. So they move in relative directions with each other, creating tectonically active areas. We know that the tectonic boundaries are the tectonic active areas, and because this region has so many tectonic plates, therefore there are a large number of tectonic areas in this region. The numerous plates create regions of subduction, continent collision, volcanic arcs. Therefore, we see a large number of tectonic activities here. We see the formation of large number of volcanoes, large number of mountains have been created here, though they are small in size, but they are distributed. Like you can see that there is Alps, there is Dinaric Alps, there is Apennines, and there are many other mountains which are created by the tectonic activities. We have already seen that there are subduction zones, Hellenic Arc and Calabrian Arc. Continent-continent collision have created Alps, Caucasus Mountains, Zagros Mountains. There is a back arc extension in Aegean Sea. There are transform faults. Anatolia Plate on the north and south boundary have transform faults. So we can see that because there are so many boundaries here, this region is very active, and that is why we see large number of volcanoes in these regions. Now let's see why there is no volcanoes in India. In India, we can see that there are no volcanoes. Now let's understand why this is so. India, when moved towards Eurasia, there was Tethys Ocean in between. However, Tethys Ocean first got subducted. It led to a lot of volcanism over here. And we see Karakoram Mountains, Ladakh Ranges, they are volcanic in origin because the Tethys Ocean which was subducting, it created large volcanic ranges. These ranges were Karakoram and Ladakh Ranges. However, when Tethys Ocean completely subducted, it was the time for collision of Indian plate and Eurasian plate. Now, Indian plate is continental plate and Eurasian plate is also a continental plate. Now, when both of these plates collided, there was no oceanic plate here to subduct. The continental crust does not subduct, we have already seen, only the continental crust mantle subducts, but the crust will never subduct, and therefore there is no volcanic activity going on here. However, Barren Island has a volcano which has recently become active. This volcano is known to exist on the Eurasian Indian plate boundary, and that is why we see formation of volcanic activity here. You can see that here is the Indian Eurasian boundary, and we know that volcanism occurs a little inside on the subducting side of the boundary. So because our Indian plate is subducting under the Eurasian plate, so we see that volcanism occurs a little bit towards the side of Eurasian plate from the margin of the boundaries. We also know that at subduction zones, stratovolcanoes are formed. So we see here that the mountain at Barren Island is a stratovolcano part. There is also another volcano called Narcondam volcano in Andaman and Nicobar, but this is almost active. It is just near to Barren Island, just on the side of Barren Island. Now we will consider East Caribbean region. We can see in this map that East Caribbean region has lot of volcanic activity, but the volcanic activity are restricted to the eastern margin of the Caribbean plate as well as western margin, but there is no volcanic activity in the north or southern margin. So let's see why. When we see the Caribbean plate, we can see that the Caribbean plate is sandwiched between the North American plate and the South American plate. Moreover, here there is a Cocos plate and Naxa plate. Now, there are a large number of plates surrounding the Caribbean plate, and we see that each of these plates moves relative to each other. Now, because of these movements, we see here a green line. This green line indicates transform boundaries. So the North American plate is moving parallel to Caribbean plate. There is no collision or divergence. Therefore, there is no volcanic region over here. Similar thing occurs in the south. In the south, we see that the South American plate forms a transform boundary. Therefore, no volcanism occurs here. But when we go to the east, we see that the South American plate is subducting under the Caribbean plate. And because it is subducting, it creates a region of volcanism. Here there are 17 volcanoes, including Mount Pelee. Therefore, this is a very active volcanic region. Similarly, on the western margin of Caribbean plate, we see that the Cocos plate is moving under Caribbean plate. That is, here is a subduction margin where Cocos plate is subducting under Caribbean plate, and thus a large number of volcanoes are formed over here. In this map, we can see that there is great amount of volcanic activity on both sides of Caribbean plate, but there is no volcanic activity in the north as well as south. Here, the South American plate is subducting under the Caribbean plate. Here, the Cocos plate is subducting under the Caribbean plate. Let's see African Rift Valley. African Rift Valley is a valley on the eastern side of Africa, which is splitting the Africa into two parts. We can see that there is a huge concentration of volcanic activities here. So let's see why volcanism occurs in African Rift Valley. Now, African Rift Valley is a very curious case. Let's see why. The rift has two branches, eastern and western, and they are separated by large distance. However, when a rift is created by a divergent boundary, then there is generally only one single rift. But here we see that there are two parallel rifts. The rift has created two domes, Ethiopian dome and Kenyan dome. And in between the two domes lies a low-lying region. The thing is that here there is a dome, that is a raised structure of Kenya. Here there is a dome of Ethiopia, and in the middle over here there are plain regions. Now this is also uncharacteristic of normal rifting. So because there is a localized effect of uplifting, it shows concentration of hot plume beneath the lithosphere. So because there are two localized domes formed here, it is believed that there lies two hot spots beneath the African plate. Now let's see the characteristics of African Rift Valley. African Rift Valley is developing a divergent tectonic plate boundary. We can see here that this is a divergent plate tectonic boundary that is created, and it is separating the African plate into two parts. The first is the Somali plate, which is moving this side, and another is a Nubian plate. So this Rift Valley is dividing the African plate into two parts. The Rift Valley is very long. It extends right in the Asia to Africa. It starts from Lebanon and it goes till Mozambique. In the Asia, it passes through Lebanon, Golan Heights, Galilee Mountains. We have already shown these locations over here. Then it passes through Dead Sea and then enters Jordan Rift Valley. Finally, through Gulf of Aqaba and Red Sea, it enters Africa. In Africa, it enters over here in the Ethiopia, forming Ethiopian highlands. There is a Afar triple junction. This is a triple junction or meeting point of all the three plates, that is Somali plate, Nubian plate and Arabian plate. Now from here it moves southwards and gets divided into two parts. The eastern margin is called Gregory Rift because he was the one who found it, and here we can see concentration of volcanic activities. We see both Kilimanjaro and Mount Kenya over here. The western side on the other hand passes through different lakes, and it is called Albertine Rift because he was the person who found it. Now let's see the structure of African Rift Valley. We already know that the Rift Valley is broader in the Afar region, and as we go south it becomes narrower. Moreover, here the lithosphere is thin, while here the lithosphere is thick compared to what it is over here. So we can very easily say that here the rifting is old or more matured, and in the southern part the rifting is quite young. Moreover, we see in the south that the rift is divided into two parts. It is believed that here there is a craton, Tanzanian craton. Now craton are oldest rocks on our continents, and it is very difficult to subduct or divide them. And therefore it is believed that it is because of the existence of this craton, the Rift Valley could not pass through it, and therefore it got divided into two parts. Now let's try to understand the formation of African Rift Valley. We already know that the Rift Valley divides the African plate into two parts. We believe that there exists two hotspots beneath African plate, and the magma from the mantle plume rises up and it collected under the lithosphere, both here and here. Because of this magma, the landform was uplifted, a bulge was created, and this led to formation of Ethiopian highlands and Kenyan highlands. Now during this bulge process, a lot of cracks were developed in the overlying landform, and through these cracks the lava made their way to the surface. So it is through this process we consider that there is a lot of volcanism in the East African Rift Valley. Now let's see all this in quick points. We have already discussed that there are two metal plumes beneath African plate, one hotspot beneath Ethiopia, which is considered to be older. The second is beneath Kenya. They heat the overlying lithosphere and make it expand, and when they expand, the lithosphere cracks. Secondly, the plumes caused formation of two thermal bulges. These thermal bulges created two highlands. One was in Afar region of north central Ethiopia and other was in central Kenya. So because of this collection of metal plume beneath the lithosphere, we see formation of these two highlands. Now when the bulges were formed, they caused stretching of the above lithosphere, and because of this there was lot of faulting which created rift valleys as well as block mountains. This means that there were very much rift valleys or block mountains were formed. Now bulging lithosphere causes cracks in the overlying lithosphere. We have already seen that cracks are created because of the bulge in the lithosphere, and through these cracks the magma from the metal plume was able to reach the surface, causing volcanic activity in the African Rift Valley. So here in this animation we are trying to show that what will be the future of African plate. You can very well see that the rift is dividing the African plate into two parts, and over the years the Somali plate will move away from the rest of African plate. Now let's see Southeast Asia. We already know that there are a lot of volcanic mountains in the Southeast Asia. So let's see why. This is the tectonic map of Southeast Asia, and here we can see that there are a large number of plates here. Pacific plate, Philippines plate, Yangtze plate, Eurasian plate, Sunda plate, Australian plate, and these plates form a large number of trenches. We can see the major trenches: Mariana Trench, Philippines Trench, Sunda Trench, Manila Trench. So there are large number of plates and large number of trenches here. These trenches or these plates have been created because this is a convergence point of three main plates: Pacific plate, Indo-Australian plate, and Eurasian plate. So all these three plates are moving here relative to each other, creating a zone of compression. So the landmass here has been divided into a large number of small micro or minor plates. Because of this large number of plates, we see large number of tectonic boundaries here. And we already know that the tectonic boundaries are seismically active areas. And because there is a lot of oceanic plate over here, when these plates subduct under another plate, they create volcanic mountains. Here are the major trenches: Mariana Trench, Philippines Trench, and Sunda Trench here, which we can see in this map. Now quickly summarize what we have discussed about Southeast Asia tectonic region. We have seen that the region is a convergence zones of four major plates: Eurasian plate, Indo-Australian plate, Pacific plate, and Philippines plate. Out of these four plates, these three plates are the major plates. They are very big plates, and when they move towards each other, a lot of force is exerted and a lot of compressive force exists if they are moving towards each other. And it is because of this plate area has been divided into several minor and micro plates. So there are a large number of minor and micro plates. Each of these plates have tectonic boundaries. So because there are so many plates, there is so much tectonic boundaries, and these tectonic boundaries are the zone of seismic activity and volcanism. Now in this region there are a large number of oceanic plates as well. So when these oceanic plates subduct, they create volcanic mountains. In fact, we can see the major trenches are Sunda Trench, Philippines Trench, Mariana Trench. The tsunami of 2004 that rocked India developed in Sunda Trench. Challenges Deep, which is the deepest point on earth, is also located in Mariana Trench. Now let's see the volcanic activity around the western coast of North America. We see that on the western coast of North America there is large amount of volcanic activity. So let's try to understand it. When we see the tectonic map, we see that there are large number of subduction zones here. There is a Pacific plate which is at some places subducting under the North American plate. There are some minor plates, John de Fuca, and along with it there are few other plates over here which are subducting under the North American plate, creating the Cascadian mountains, the Rockies mountains. Here we see the famous San Andreas transform boundary. This is a major source of earthquakes here and passes through the Californian Gulf. This is another diagram of this region, and we can see that John de Fuca plate is subducting under the North American plate, which is creating a subduction zone here, and that is why there are large number of volcanic mountains on the margin. Now let's discuss all the points quickly. San Andreas transform fault is a very famous transform fault located between Pacific plate and North American plate. It passes through Gulf of California and it is a source of large earthquakes. Cascadian subduction zone is a subduction zone which creates our Cascade Fold Mountains. It is created by John de Fuca and Goda, both minor plates subsiding under a very large North American plate. Then we have Aleutian Trench in the north. It is formed by the subduction of Pacific plate under North American plate. We see volcanic island arcs forming here. Now let's see western coast of South America. This is a very famous boundary. We see a lot of volcanic activities occurring on the western margin of South America. Here our Nazca plate is moving under South American plate and it has created a very large trench. Moreover, a subduction zone is created over here. Now we know that when an oceanic plate subducts under a continental plate, we see volcanic arcs are found. So here the Nazca plate is subducting under South American plate and it creates a volcanic arc which we call as Andes Mountains. Notes for all the topics that we discussed will be available on our website zeta-access.com. Thanks for watching the video, and if you like the video, please like, subscribe and share. If you like our effort and like what we are doing, then you can use our UPI ID or Patreon ID to support us. You can follow us on our social media links. Until then, we meet again. Jai Bharat, Jai Gyan. Thank you.